So let's do one more. This time we'll go ahead and actually express the equation already in polar form. So give us a little practice in graphing also. So example 5. Okay, find the integral of f of xy is equal to x squared over the region contained by r equals 1 minus cosine theta. So in this particular case, they gave us the equation, the particular region, in polar coordinate form already. Okay, let's go ahead and draw out what this region is. When you do a table of values or when you put it into your calculator, you're going to end up with something that looks like this. It's called a cardioid, and it happens to be, it's called a cardioid because it looks like a heart. That's it. So in this particular case, so this is the region that we're concerned with. We're going to be integrating over this region, and we're going to be integrating this function. So let's go ahead and find what r is. So r is going to run, it's going to be greater than or equal to 0, less than or equal to, well, 1 minus cosine theta. So in this particular case, this is an actual function, not specific values, just like before. You know, we can have a function in the inner integral. It goes from 0 to 1 minus cosine theta, whatever that happens to be, and theta is going to run from 0. We're going to start with 0, and we're going to go all the way around, sweep all the way around to 2 pi. So that's it. So these are our upper and lower limits of integration. So now let's go ahead. So let's do f of t. Well, x squared is r squared cosine squared theta. So the integral equals, well, theta is going to run from 0 to 2 pi. X is going to run from 0 to 1 minus cosine theta. Our integrand is r squared cosine squared theta, and our area element is r dr d theta. It's my recommendation to always put the r dr d theta there, and then if you want to, you can go ahead and rewrite this as r cubed cosine squared theta. It's good practice, because a lot of times you'll just sort of forget the r. Make sure it's there. So let me put little parentheses around it so you know that those are actually separate things. This is the integrand. This is the conversion factor, if you will. And then when you put this into mathematical software, you end up with the following number, 49 pi over 32. So you see, it wasn't 0. So that was just a coincidence that we kept getting integrals that were 0. Okay, and that's polar coordinates, and that is integration in polar coordinates. Thank you for joining us here at Educator.com. We'll see you next time. Bye-bye.